Hi and hello dear friends, welcome back once again to our channel VAAGAI Academy of Mathematics, and this playlist is where you will find video lessons for CBSE Class 7 Applied Mathematics. So we have already completed the first three exercises 7.1, 7.2 and 7.3 from the concept of permutations and combinations, and following those exercises here this session we are about to work exercise 7.4 from permutations and combinations and from a standard book ML Aggarwal and Neeraj Raj Jain. So if you see the previous exercise, there we dealt about all those basics of permutations and combination, and that too the recent exercise, the last one, there we dealt problems which are based on arranging objects which are distinct. So there will be some distinct objects and we need to arrange those distinct objects, and how many possibilities are there, how many ways are there. That is how we had problems there. When you come to this exercise 7.4, here we have got problems which are based on arranging identical objects. So they are given some objects. What if some of them are identical? Then what can be done? This is what we are going to deal here with the problems of this exercise 7.4. Fine. Yes. So I think it would be better if we just have some intro and the concept. We just see the concept, the way of approach, how we can solve problems of such type. It will be easy for us to solve problems, the other exercise problems. Okay, all right, yes. Yeah, coming here, identical objects. Let's take a plain example, a very clear basic example. See, there are totally 4 fruits. There are 4 fruits there. There's one apple, one mango, and there are 2 bananas. So totally there are 4 fruits, right? 1 plus 1 plus 2, there are 4 fruits. And for some identification, what we can do here is, we'll name the apple as A. We'll name the mango as M. And there are 2 bananas here, right? Okay. As of now, what we will do here is, we'll just take the bananas to be B1 and B2. I hope it is clear to you. Okay, we'll take them as B1 and B2 because there are 2 bananas here, right? Yes. So that means totally there are 4 fruits here. Now, my question is, in how many ways we can arrange these 4 fruits? This is going to be the question. So I think the way of answering this question is going to be very easy. There are 4 objects and we can arrange these 4 objects in how many ways? We can arrange it in 4 factorial ways. Very simple. Okay, 4 factorial ways. So this is how we had problems from the previous exercise, right? So 4 objects. So there will be 4 factorial ways. So my answer will be 24. That's going to be the answer. And see, this is when our objects, all the objects are considered to be distinct objects. Distinct means they are all different. They are not alike. That's the meaning. Okay. So one apple, one mango, and there are 2 bananas. And what we did here is, to solve this problem, this situation, what we assumed is, we took the bananas to be B1 and B2. This is what we did. So that means when we see here, there are like 4 distinct objects. Is it or not? So that means our answer is 4 factorial, which is 24. That is going to be the answer. Now, what if these 2 bananas are considered to be identical? Identical means both of them look alike. I mean, the way we are going to order or we arrange those 2 bananas, the order of those 2 bananas will not disturb the overall arrangement. What if we have a condition in that manner? In that way, if we have a condition, then what approach we should take to solve the problem? So that is what we are going to see here. So if the 2 bananas are going to be distinct, then answer is going to be 4 factorial. But what if they are going to be identical? They look alike. Or the way we are going to swap the arrangements, it doesn't affect the answer. Now what is going to be the thing? Then how we can approach it? Just think of, here we have got 2 bananas, right? So since there are like B1 and B2, we have like, they are like 2 distinct objects. So we had totally 4 objects, so 4 factorial. But now, since I take them as both to be identical, we will just remove those suffixes, okay? Like we'll have it as B and B. Now there are like 1 apple, 1 mango and 2 bananas, and there are identical. That's it, okay? Now I am not differentiating by giving any particular notations for those bananas. There are 2 B's and each of them, I mean both of them are going to be like, they are going to be identical. That's the meaning. Okay. Now what happens is, here when they are distinct, there are like two different objects. Now those two different objects within themselves can be arranged in how many different ways? They can be arranged in 2 factorial ways. Is it or not? Yes. I mean, like when they are distinct, when they are distinct, they are not alike, there will be 2 factorial ways. But now what has happened is, now here they both are going to be identical. In this case, what happens? This 2 factorial extra repetitions are going to be like what? They are going to be like repetitions only. Fine. Okay. Yes. Repetitions in the sense we are going to get some copies of that original only. So for that reason, in order to avoid those copies, what we do here is, with our original 4 factorial, the total number of 4 factorial ways, now in order to get rid of those extra copies, I can tell it as extra copies. Fine. Okay. What we can do here is, I can divide this by this 2 factorial number of ways, because in each of those 4 factorial ways we will be having like 2 factorial extra ways. So to avoid those extra copies is what we need to divide by 2 factorial, and this will give you the answer. Okay. Now what will be the complete answer? So the answer is going to be 4 factorial, which is 24, divided by 2 factorial, which is simply 2, right? Yes. So our answer is going to be 12 is going to be the answer. So that means whenever we come across identical objects, then what we have to do is just see the individual number. Just see the overall count. How many are there? Just take that factorial and divide it by, what we have to do here is, and divide it by how many of them are identical. That identical numbers factorial with which we have to divide it. This is what we have to do whenever we have questions which are based on identical objects. I hope you are able to understand this. And the reason why we divide that, the reason is just to get rid of those extra copies is what we are doing this division. That is the reason. Okay. All right. So this is what we need to do in order to solve problems based on this distinct objects. I hope this idea is now very clear to you. I think now it will be better if we solve problems from the exercise. Yes. Okay. We'll go for the exercise problems. We'll go solve those problems, and there will be some extra conditions also. I think it will be better. It will be better if we just go solve the problems. There itself we learn the other extra concepts. Okay. All right. Yes. We'll start solving the problems. First question. Here we have, in how many ways can 3 white, okay, let's note it, 3 white, 4 red and 1 blue marbles be arranged in a row. Okay. So we need to arrange these marbles in a row if the marbles of same color are indistinguishable. Fine. Okay. This is going to be the question. Okay. So that means same colored marbles are indistinguishable. That means like the meaning is what? They are all not going to be distinct. It is like same colors are like identical. Fine. Okay. This is what they are coming to say here. So that means what color marbles and how many are we having here? There are 3 white marbles. So we'll note it. 4 red and then 1 blue. So these can be arranged in how many ways? This is going to be the question, right? So total number of ways is going to be, our answer is going to be. So first of all, see totally how many marbles are there? There are totally 3 plus 4 plus 1. Is it or not? So that means there are 8 marbles. That means those 8 marbles can be totally arranged in 8 factorial ways. This is okay. But we have to divide this 8 factorial by what? See, we have here, there are identical objects. Is it or not? Same colors are like identical. That means just see how many of them are identical. There are 3 white marbles. So that means those 3 white marbles can be arranged in 3 factorial ways. So divide by 3 factorial. And 4 red marbles, they can be arranged in another 4 factorial ways. So divide by 4 factorial. And 1 blue is like 1 factorial, or we can even leave it. Okay. Just for clarity, we can even write it. So 1 factorial, because it is like there's only 1 marble, right? So that means it can be arranged in 1 factorial ways. Okay. We can even leave it. It doesn't affect the answer. So this will give you the overall answer. Okay. I hope you got the reason why we divided by 3 factorial, 4 factorial, everything. So the reason behind that is because they are identical. That's the reason. Very simple. Okay. This is what we saw there in the introduction part, right? The same logic follows. All right. Okay. Yes. Now we simplify this. We'll be able to get the answer. So how we can simplify this? Let's try to do it in a smart way. Okay. All right. So first of all, we'll start with the numerator. Numerator, we have got 8 factorial, right? So that 8 factorial, let me expand it. Okay. So how we can expand this is, 8 into 7 into 6 into 5 into, and then follows what? We will be having 4 factorial, is it or not? So into 4 factorial divided by, here we have 3 factorial, right? This 3 factorial can be written as 3 into 2 into 1 into, here we have 4 factorial. Let me write that 4 factorial as it is, because now I can easily cut this 4 factorial. We have a numerator and denominator, we can easily cut it. Okay, all right. Yes, is the idea clear? This is what we do here. So 8 factorial I expanded using factorial's property. So I got, or I tried to express it in terms of 4 factorial, because the reason I have 4 factorial in the denominator, that's the reason. So now it is very easy for me to cut it, right, from both numerator and denominator. That's the reason I expanded like this. Now we have only numbers. We are now free from factorials. We have got only numbers, multiplications. Now we can simplify it, right? Okay. So how we can simplify this is, next we have 8765 in the numerator and denominator 321. That's it. Okay. And anyways, I'm not rewriting this 1 factorial here, because 1 factorial is going to be again 1 only. There's no use of again dividing by 1. That's the reason I left it. So now we have this 3 2's are to be cut with this 6, right? Because 3 2's are 6, right? I can cut this with this 6, and now we are simply left with 8 into 7 into 5. So basically 8 5's are is 40, right? 5 8's are is 40, and 40 into this 7 will give you 280, and that is going to be the answer for your question number 1. To question number 2, here our question is, how many different signals can be transmitted by hoisting 3 red, we'll note it, okay, 3 red, next 4 yellow and 2 blue flags. So there are 3 red, 4 yellow and 2 blue flags. This is what we have on a pole. Assuming that in transmitting a signal, all 9 flags are to be used. So if you check the total, there are totally 9 flags, right? So there are 3 plus 4 plus 2. This will give you total 9 flags. Okay, fine, all right. So that means when you transmit a signal, all the 9 flags should be used. This is the condition given, are to be used, and flags of the same color are indistinguishable. So the same condition, how we had the previous question, the same way here also we have the color distinction. Okay, so we don't have any distinction in the colors. I mean, like same colors are like identical. That is the meaning they are coming to convey here. Okay, flags of the same color are indistinguishable. This is what they are given here. So again, we are going to handle the same kind of approach to solve this problem also. Okay, so that means the number of ways, the total number of ways is going to be how much here? So totally there are 9 flags. So those 9 flags can be arranged in how many possible ways? Totally 9 factorial ways, but among which how many of them are identical? Same colors are identical. That's it, right? So that means 3 red is there, so 3 factorial, and 4 yellow, for which we have a 4 factorial, and 2 blue, again we have a 2 factorial. So that's it. Now we simplify this expression, we can get the final answer. Very easily we can get the answer. Okay, let's carefully try to simplify this. So how we can begin here is, here again we'll try to express this 9 factorial in terms of this 4 factorial. Okay, let me give you the idea. The idea is going to be very simple. See the denominators. Now among the denominators, the biggest number which is having the factorial is this 4 only, right? Is it or not? So in that case, just try to express this 9 factorial in terms of this 4 factorial. That's it. That is going to be the simple idea. Now when I try to do that, what happens is, this 9 factorial I can rewrite it as 9 into 8 into 7 into, just write the descending order. Okay, 9 8 7 6 into 5 into, stop it, now 4 factorial. That's it. Do like this. Fine. Okay, divided by. Now expand this 3 factorial. Okay, 3 factorial, if you expand, this becomes 3 into 2 into 1 multiplied by. Now this 4 factorial, please don't expand it. Okay, why? Because now I can easily cut these 2 4 factorials what we have in the numerator and denominator. For that purpose is what we expanded our numerator like that. Fine. Okay, so no need to expand this again for a length 4 factorial. Okay, anyways they are going to be cancelled, right? That's why. Multiplied by, again we are left with another 2 factorial. So 2 factorial is going to be 2 into 1 expanded. That's it. Okay, now we are again free from factorials. All numbers only we have. Now we can as usual play simplifying the problem. Okay, so this will be equal to, So yes, how we can cancel here is, we can again cut this 3 2s are with the 6. We can do that, right? Yes. And what next I can cancel here is, we are also left with another 2 in the denominator. So this 2 I can cancel with some number in the numerator. So I think the only number with which we can cancel is this 8 only, because there is the only even number, right? Others are all odd numbers. So 2 and 8 exactly 4 times. So now we are left with 9 into 4 into, here we have a 7 into and 1 5. This is what we have here. So this will give you the answer, right? So this will be equal to, so just take the numbers, okay? Make your choice in a nice way. 9 7s are 63 multiplied by 4 5s are is another 4 5s are is a 20, right? So that means we have 63 times 20. So 63 into 2 will be basically 126 and place a 0 there. So 1260 will be the final answer for this question number 2. Moving to question number 3 here. We have a very simple kind of question, but this will involve some great amount of calculation, right? Okay. So yes. The question is, find the number of arrangements that can be made out of the following words. This is going to be the question. So we have got totally 6 subdivisions here. So we need to work them one by one. So in each of these subdivisions, we have got one word, and we need to find the number of ways in which we can arrange the letters of the word. This is going to be the question. Okay, this is going to be the idea. The idea is going to be very simple, as I told, but we need to carefully perform the calculation. That matters. So let's carefully do that. First question, we have the word root, R-O-O-T. So in how many ways we can arrange it? This is going to be the question, right? So that means the total number of ways is going to be, totally there are how many letters available? R-O-O-T. There are totally 4 letters. So 4 factorial divided by, now see among which how many of them are identical. That is important, right? Now there are 2 O's. The letter O is repeated twice. So that means we have to divide it by a 2 factorial. This is the idea. Fine. Okay. So this is what we did for the previous questions also, right? So here also these 2 O's are like 2 identical objects. So that means we have to divide it by 2 factorial. That's it. Very simple. So 4 factorial divided by 2 factorial will give you the answer. So our answer is going to be what? So this will be actually 24 by 2, and that means the answer is 12. Simple. That's it. Finished. So 12 is going to be the answer for your first subdivision. Coming to the second subdivision, here we have the word banana, B-A-N-A-N-A. So this is our word, and this can be arranged in how many ways? Just see how many letters are there totally. Just have the total count first of all. Okay, 1, 2, 3, 4, 5, 6. There are 6 letters. So 6 factorial divided by. Now see the letters which are repeated. Okay, all right. So that means if you check for the repetitions, there are 3 A's available, is it or not? Because B-A-N-A-N-A. There are 3 A's there. So 3 A's for which we have to divide it by a 3 factorial. And see whether there are any other repetitions. Yes, the letter N is also repeated, right? So N is repeated for twice, 2 times. So that means divided by another 2 factorial. That's it, very simple, okay? So our overall answer is going to be 6 factorial divided by 3 factorial into 2 factorial. This is going to be the answer. And now we need to simplify this. So if we try to do that, what happens is this 6 factorial can be expanded as 6 into 5 into 4 into 3 factorial. Is it or not? Into 3 factorial. Let me not write it there. So 6, 5, 4 into 3 factorial. The reason is that 3 factorial will be divided by this 3 factorial. That is the reason. And simply we will be left with only 2 into 1 here in the denominator. I hope you are able to understand it. So 6, 5, 4 into 3 factorial, which will be in turn divided by this 3 factorial, what we see here in the denominator. And we will be simply left with only this 2 factorial, which is going to be 2 into 1. That's it. Okay. So now when you try to simplify this expression, we will be having the answer to be what? So now I can cut this 2 and this 6 also I can cut it. So when you try to cut it, it will be like exactly 3 times, right? So our answer is going to be 3 into 5 into 4. This is going to be the answer. So what will be the answer? Answer is going to be 60 is answer, because 5 4s are is 20 and 23s are is going to be 60. That means answer is 60 for this question. I hope you can understand this. Coming to the third subdivision, here we have the word apple. Again, another fruit we have. So apple, this can be rewritten in how many ways? So apple can be arranged in how many ways is? I think it will be better if I just place a line so that we need not confuse with the answers. Yes, now I think this looks better. So apple, this can be arranged in how many ways? There are totally how many letters available? There are 5 letters. So 5 factorial now divided by, see the repetitions in the letters. So there's only one letter repeated, that is P. P is repeated for 2 times. There are no other letter repetitions happening here. So there are 2 P's here, so for which we have to divide it by a 2 factorial. I think the idea is clear to you. So now our answer becomes 5 factorial, which will be 120, divided by a 2 factorial, which is 2. So our answer will be again 60 is going to be the answer for your third subdivision. Yes, let me put a line. And next we have fourth subdivision. Here we have the word pineapple. So as we proceed to the questions, the words are becoming very longer, right? So that means we should understand that the calculation work is going to be very huge. That's it. So yes, anyways, pineapple. So see the word pineapple. Here we have how many letters in the question? Just see 1, 2, 3, 4, 5, 6, 7, 8, 9. There are totally 9 letters. So take 9 factorial and we must divide this 9 factorial by what number? Just see for repetitions whether any letter is repeated. Yes, there are letters repeated. There are 3 P's available, right? 1, 2, 3. There are 3 P's available. So that means I can divide by 3 factorial. And do you see any other letters repeated? Yes, of course, the letter E is also repeated, right? So E is appearing for 2 times. So there are 2 E's here. So again, divided by a 2 factorial. And check for whether any other letters repeated. So there's 1 I, 1 N, 1 A and 1 L. So they are all going to be distinct letters only. So no issues. That's it. 9 factorial by 3 factorial into 2 factorial. This will give you the answer. And as usual, what I can try to do here is just be careful what we are doing here. Okay. Or yeah, I think this space is enough. So provided if we do it very carefully. So 9 factorial will be written as 9, 8, 7, 6, 5 and 4 divided by, I'm not writing the extra part there. Why? Because I hope you understood the reason, you got the reason. 9, 8, 7, 6, 5, 4, you must have that extra 3 factorial, but I am not writing it just because I have a 3 factorial here in the denominator. They both will be cancelled off. So you will be simply left with only this 2 factorial what you see in the denominator, which is going to be 2 into 1. Yes, I hope the idea is clear to you. Now you simplify this, you will be able to get the answer. So now what will be the answer? Answer will be equal to, so yeah, let's carefully work it out. So when you try to do it, we'll have this 2 and this 4 cancel for exactly 2 times, right? So yes, hold on. Now we have 9 8s are 72, right? Or we can do it the other way, right? So I have 9 6 are 54 and 8 7s are is 56. Am I right? Yes. So we have 54 into 56 into this 5 2s are is a 10. I hope it is clear to you. So we have 9 6 are 54, 8 7s are 56, 5 2s are 10. So let me segregate the numbers like this. Now we can first try to multiply this 54 into 56. Let's do this calculation. Okay. So when you try to do this calculation, how easily we can perform this? 54 into 56. If you want, you can multiply it separately, but I will try to do it in a shortcut trick possible. Okay. So 54 into 56 can be basically written as 55 square minus 1 square. You agree with that? Yes. Why? Because this is like a minus b into a plus b. I'm considering this as 55 minus 1. This as 55 plus 1. So that means this becomes a plus b into a minus b, which will be a square minus b square, and that's how I got the logic. So when I try to do that, I will be getting 55 square minus 1 square, which will be 3025 minus 1, which is 3024. So I will be getting 3024 here for this product, and I have an extra 10 also. So that means there will be a 0 attached here. So that means our overall answer is going to be 30,240 is going to be the answer. Yes, smooth, cool. We finished it. And yeah, coming to the fifth subdivision here, we have the word institute given, right? So as usual, what we can try doing here is, we'll see the number of letters, total number of letters here. So if you see that, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, there are 9 letters. So 9 factorial. Now that has to be divided by, just see the letters repeated here. So we have the letters repeated are, this I is actually repeated, right? So now there are 2 I's here, right? There are 2 I's. So that means like we have two i's. There are two i's here. So 2 factorial, and what next we have here is, we have any other letters repeated? Just check it. Yeah, of course we do have the letter T repeated, right? So T, T, T. There are 3 T's here. So divided by 3 factorial. And what next we have? We have other letters. Yeah, others are distinct letters only. So there's nothing to do division. So hereafter there's no division needed. 9 factorial by 2 factorial into 3 factorial. This is going to be the answer. And I think the same expression is what here also we got here, right? For the previous question, 9 factorial by 3 factorial into 2 factorial. They both are same, right? That means answer is also going to be the same. So 30,240 is going to be the answer. 30240 is going to be the answer for your 5th subdivision again. So our task was made more easy here. So yes, last subdivision we have the word civilization. The given word is civilization. Of course, the longest word here out of all these given subdivisions. This is the longest word, civilization. So for which we need to find the number of arrangements we can do here. So there are totally how many letters? From there we have to start. So total number of letters is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. That means 12 factorial. We have exceeded 10. Okay, fine. Yes. So 12 factorial has to be divided by. Now just check whether there are letters repeated. Yes, shall we check? Yes. So C, no, there's no repetition. A is not repeated. Z is not repeated. L, A, T, none of them are. Only I, the letter I is repeated, right? I is repeating for, there's one I here, 2, 3 and 4. There are 4 I's. So that means divided by 4 factorial. I don't think that there is any other letter repeated, right? Now all the other letters are distinct only. So that means 12 factorial by 4 factorial is going to be the answer for this question. And of course we need to expand it to get the final answer. So what can be done here is, we can expand the 12 factorial, right? Yes. If we try to expand it, what happens is like 12 into 11 into 10 into 9 into 8 into 7 into 6 into 5 into what? Into 4 factorial. That is what will come there when you follow it. So 5 into 4 factorial, and that will be again divided by 4 factorial, leaving your expression simply with this alone. Yes, fine. I hope you are able to understand that. So anyways, we try to expand this 12 factorial in terms of 4 factorial, and those 4 factorials, what you see in the numerator and what you have in the denominator, they both get cancelled off, and simply you will be left with only this expression. And so your answer will be this expression. Okay, fine. Yes. So of course we do have big numbers. We have to carefully multiply to get the answer. So what can be done here is, we'll try to just segregate the numbers, just group the numbers in a good possible way. Okay. So first of all, I will try to take this 11 9s are. 11 9s are will be a 99. Over, done. Okay. Multiplied with. Next, we will collect numbers which have zeros, right? Okay, zeros means we have a 10 is there. 10 is a good number, and I can even have 10, 8, 5. I think we can group this 10 into 8 into 5, right? Because 8 5s are is a 40. 40 10s are is 400. Okay, so this is giving some good number, again a good number. And next, what next we have here is, what are the other numbers left? Other numbers left are this 12, and we have this 7, and we have this 6. So only these 3 numbers are left over here. So now we will multiply those 3 numbers. I think 12 6r will be 72, right? 72 into 7 will be equal to 504. So 504. So this huge calculation, if we are able to complete, then we can get the answer, I think. So just check whether we have missed any numbers. Just check. So 11 9s are 99. 10 into 8 into 5 is 400, and 12 into 7 into 6 is going to be another 504. Why? Because 12 6 are 72, 72 7s are 49, 14. Yeah, 504. So this is what we have here. So that means we have 99 into 400 into 504. Again, we'll try to do some tricks here. Okay, so let me rewrite this as 99 into 100 into, okay, and just changing this 400 as 100. For the reason I'm going to multiply the 4 here. If I multiply it by 4 here, what happens is, this 504 into 4 becomes 2016. I hope you are able to understand this, what we are trying to do here. Yes. because 5 4s are 20, 4 4s are 16, right? Yeah, of course, 2016. Just only thing what I try to do here is just I transferred this 4 from here to here. That's it. Okay. Now we are left with 99 into 100 into 2016. So just do a simple thing. Just first multiply this 2016 into 99. Okay. For which what can be done is just do the easy process. Okay. 2016 into 100 just minus 2016. You will be easily able to get the answer, right? Okay. Yeah, fine. So once you try to do this, your answer will be 584 here, 584, and here we have 199, right? Yes, because 600 minus 16 will be 584 and 201 minus 2 will be 199. So 199584 is what is the answer when you multiply 99 into 2016. But again, we need to multiply this product by another 100. That means attach 2 more zeros here. That's it, finished. And this will be the answer. I hope the process what we carried out here to solve the answer is clear to you. I tried to multiply 99 into 2016 first, and that is what is giving me this answer. This is simply nothing but 2016. I am multiplying by 100. From that, I am removing 2016 so that I can easily get the answer for 2016 times of 99. That's it. Okay, and I got it here. I am attaching 2 more zeros just because I need to multiply by another 100. That's the reason. Okay, fine. Yes, so 19958,400 is going to be the answer for your last subdivision. So I think successfully we have completed the third question also. So these are going to be the answers for your question number 3. Next we have another good interesting question with us. Question number 4. In how many different ways the letters of the word algebra, okay, so our given word is algebra, that can be arranged in a row if we have got 2 conditions as 2 subdivisions. So let's see them one by one. Okay, the first one says the 2 A's are together. This is going to be the question. So of course, if you look at the word algebra, the given word algebra, what we have in the question, there are 2 A's here. Is it or not? Fine. Yes. So there are 2 A's. Those 2 A's should be together. That is what we are given there in the we are given as the condition in the first subdivision. Okay, fine. Yes. So in that case, when the 2 A's should be together, our arrangement will be like what? We'll just put the 2 A's together like this. I'm just placing the A's next to each other. And what next I will try to do here is we will just write the other remaining letters. Okay. So other letters are L, G, E, B, and R. So yeah, these are the other letters, right? So this is what we have here. So that means we will just try to take these 2 A's together. So that means we will make them as a single bunch. I hope the approach is very clear to you, because we have dealt with similar kind of questions in our previous exercise also. So whenever we have the condition, they should be together. Then what we try to do there? We always just try to put them inside one single bunch, right? Okay. That means these 2 A's are inside one bunch. That means this is now for us only one single object. Fine. Okay. All right. So that means here our task is like we have to arrange how many objects? We need to arrange 1. Just remember 1, 2, 3, 4, 5, 6. There are 6 objects here. Is it or not? That's it. Okay. Because these are all like distinct objects, and these 2 A's will now be like one single object. So that means we have 1, 2, 3, 4, 5, 6. There are 6 objects here. So that means in how many possible ways we can arrange these 6 objects? We can arrange these 6 objects in 6 factorial ways. Fine. Okay. All right. So we can arrange those 6 objects in 6 factorial ways. But hold on, our condition or our answer is not yet over. What next we have to concentrate? We have to again concentrate that bunch inside that bunch. What happens? That also we have to look, right? So now what happens is inside the bunch, if you see, there are 2 letters, and those 2 letters can be in turn arranged in 2 factorial ways. But again, those 2 objects what you have inside that bunch, there are 2 objects. Of course, there are 2 objects, so 2 factorial ways. But divide that by what? Those 2 are identical, right? So that means again we have to divide it by a 2 factorial. I hope the idea is clear to you. Okay. If at all there is no repetition, we can leave it as it is 2 factorial. That's it. But since we have 2 letters, and those 2 letters itself they are going to be like what? They are going to be identical objects. What we can do here is they are similar, right? They are same objects. They are similar objects. So that means they are identical objects. I am dividing by 2 factorial, because there's a repetition, that's the reason. Okay, so that means my final answer is going to be 6 factorial. Anyways, these both are going to get cancelled. 2 factorial by 2 factorial, it's going to cancel. So simply 6 factorial is going to be the answer. And what is 6 factorial? 6 factorial is going to be 720, and that is going to be the answer for your first subdivision. Okay, all right. Now interesting second subdivision. Now when you come to the second subdivision, the interesting part is in how many ways the letters can be arranged in such a way that the two A's are not together. This is going to be the question. So if you look at the first one, the two A's should be together. That's a condition. But when you look at the second subdivision, the two A's are not together. That means the two A's should not be next to each other. We can tell like that, right? They are not together means we should not have the two A's like this. That is the condition. That's it. Very simple. Now just think of very carefully. Just think of, if the two A's should not be together, then what can be the answer? That means the simple thing what you can do is, you just first of all calculate the total number of A's. You calculate the total number of A's, and from this total you just remove the A's are together. The A's are together. Just we will remove this, so that now we can very easily attain the answer. I hope this approach is clear to you. So the total number of ways in which we can arrange all the letters without any condition, without any restriction, in how many ways we can arrange, that is your total. Now from that total, what we do here is we minus the number of ways in which the A's are together. Why? Because from total, if you remove the number of ways in which the two A's are together, you will obviously get the number of ways in which the two A's are not together. That is the objective. Very simple. Okay, because in these many ways, in 720 ways if they are together, then definitely in other ways they are not together only, because there are only two objects only, right? If there are more than two objects also, we can think about the possibility. Which possibility? That is, if there are, suppose for an example I am telling, okay, because this clarity you must have, that's the reason. We can use this advantage only when you have two objects. That also we have to keep it in our mind. I will tell how this is going to contradict when you have more than two objects, okay. Let's take an example of, let's take a case of three objects are there. Now if there are three objects, we cannot use this object, this approach, we cannot use this approach, okay. Definitely we can't use this approach. Why? Because if we try to minus it like that, then what happens is any two of them will be together and one will be away, right? Okay, so those different possibilities are possible there, right? That is the reason that we can't use. But here, since there are only two A's available, we can definitely use it. Okay, there's no objection at all. There won't be any confusion at all, because in the ways out of wherever the two A's are together, except that the other ways they will be definitely not together only. That's the reason. Okay, that's the reason we are taking this approach, total minus the A's are together. Okay, now our objective is to find the total number of ways in which we can arrange these words, I mean these letters in the word algebra. Okay, so that means our algebra has got totally how many letters? Just check and see. 1 2 3 4 5 6 7. There are 7 7 objects are there. So 7 factorial divided by what? So how many letters are repeated here? How many letters are repeated? There are repeated letters, are the two A's are only repeated. That means 7 factorial by 2 factorial minus in how many ways A's are together? That is what we got just now. That is going to be a 720. So we simplify this to get the answer, right? So we know that 7 factorial is what? 7 factorial is 5040 divided by 2 factorial, which is 2. So 5040 divided by 2 will give you 2520. So 2520 minus 720 will give you the grand answer. So this is going to be what? Anyways, 20 minus 20 will be 00, and we are simply left with this 20 minus 20 is giving you this 00. Okay, all right. And now we are simply left with this 25 minus 7. What is 25 minus 7? That is going to be 18. So 1800 or 1800 is going to be the answer. Okay, I hope this approach is very clear to you. Fine. Yes. So the first subdivision what we try here is the two A's are together. That is like in the usual way we can do. The vowels are together, the digits should be together. We dealt with similar kind of questions in the previous exercise. The same way we can just approach this question also. You take them as a bunch and then you carry out the problem, you work it out, you get the answer. And next, second subdivision, here we have the two A's are not together. So just because there are only two objects, we can definitely, without any restriction, without any doubts, we can definitely use this approach. Total minus A's are together, and that is what we are doing here to get the answer. So yes, first subdivision the answer is 720, and second subdivision the answer is 1800, and these are going to be the answers for either question number 4. Yes, let us go to the next question. Question number 5 here. How many different words can be formed with the letters of the word university so that all the vowels occur together? So this is going to be the question. All the vowels occur together. Okay. So the given word here is university. Okay. Let's just make a note of it. University. So this is going to be the word which is with us. So using these letters in this word, we have to form words, new words. That means we need to arrange the letters of this word in such a way that all the vowels occur together. This is going to be the question. So this is going to be, what to say, we have dealt with very similar kind of questions, right? Vowels are together. We have worked out many questions based on the same concept. So we have a similar question only appearing here. So let's see the approach how we can solve this problem. So first of all, we will just see our word and we will just collect the letters which are vowels first. Okay. So we know A, E, I, O, U. These are going to be the vowels. So in that case, what vowel letters we have here are U is a vowel. Okay. So we have the letter U. This is a vowel. Then I is a vowel. Then E is a vowel. And then any other vowels we have. Then again I is a vowel. So that's it, right? Only these are going to be the vowel letters available here in our word, and the rest are going to be consonants only. Is it or not? So let's note those consonants also. So consonants are going to be the other letters, just the other letters. So they are going to be N, V, then R, S, T, Y. So these are going to be the other letters. So now our task is the vowels should be together. In that case, what we have to do here is, as usual, we will make this vowels to be one bunch. Okay, we will just take this vowels to be one single bunch. That means like this is going to be one single object for us now. This is one object and these are all going to be one objects. Okay, so that means here our task is like arranging how many objects? How many objects are we going to arrange here? 1. Just count this as 1. Okay, 1, 2, 3, 4, 5, 6, 7. So that means there are totally 7 letters available. Okay, so that means total number of ways, the number of ways in which we can form new words is going to be equal to, how many are there? There are totally 7 objects. Is it or not? So 7 factorial. So here if you see, this is one object, and here if you see the other objects, N, V, R, S, T, Y, none of them is repeated, right? So that means it is going to be simply 7 factorial. Okay, fine, yes. But for each of these 7 factorial ways, what next we have to see? We have to now go inside that bunch, because inside that bunch we have got 4 letters, right? Those 4 letters are vowels. Of course, they are to be together. Those vowels should be always together. That is okay. But within themselves, they can be in any order they want. Is it or not? So that means these 4 vowels can be arranged in different ways. How many ways we can arrange these 4 vowels? So that means there are 4 vowels here, right? So that means 4 factorial. But hold on, this 4 factorial, but again we have to divide this 4 factorial by what? Now see here, out of these 4 letters what we have here, 2 of them are identical. So for that reason, I have to divide this 4 factorial once by 2 factorial. I hope you understand the reason, right? Is it or not? So just be clear with each and every numbers, these factorials, these notations, why we are placing. We should be very clear in reasoning that. Fine, okay. Let me repeat it. See here, we have made this entire vowel collection, so letters as one single bunch. So that means this is like one object for us now. So 1, 2, 3, 4, 5, 6, 7. So totally 7 objects for which 7 factorial multiplied by, now within vowels we have 4 vowels. Okay, within this vowel bunch we have got four letters there. So 4 factorial divide by, that should be divided by, among which 2 of them are identical. So we are dividing by 2 factorial. Okay. If at all we have any letters repeated here, we have to divide by that factorial by this 7 factorial also. That also we have to remember. But since here there's no letters repeated, we are not dividing by anything here. But here we have repetitions. That is the reason we are dividing by 2 factorial. Okay. Fine. Yes. So this is all we have here. And now if we are going to simplify this, we will be able to get the answer. So answer is going to be what? So we know 7 factorial is what? 7 factorial is 5040, 5040. This is multiplied by what? This is going to be multiplied by 4 factorial by 2 factorial. So what is basically 4 factorial? 4 factorial by 2 factorial means this is like 24 by 2, which means 12, right? So 5040 into 12 is going to be the answer. So now we want to divide this. So sorry, we have to now multiply these numbers, right? So 5040 into 2, this is what we have to do here. So I think we'll separately work it out, right? Because 5040 into 10 we will be getting 50400. This is what we'll be getting. And 5040 into 2 if you do, 5040 into 2 if you do, we'll be getting 10080. This is what we'll be getting, is it or not? So that means our overall answer is going to be what? Our answer is going to be 60480 is going to be the answer. So we'll just note this, and this is going to be the answer for your question number 5. Next we have question number 6 with us. Here, in how many ways can the letters of the word assassination, okay, so our given word is assassination. So I think it will be better if you just write the word. So we'll write it once again, ASSASSINATION. Okay, of course a very long word we have here. And yes, in how many ways we can write the letters, okay, in how many ways we can arrange the letters. So be arranged so that all the S's are together, okay. That means in this given word, in how many ways we can rearrange the letters of this word in such a way that all the S's are together. This is going to be the question, very interesting question, and of course it's going to be very easy also. So like we are, if you are much clear with the previous questions, this question is going to be nothing, okay, fine, yes. But provided we should be clear with the calculations, because it's a very long word given, so we should be careful in doing those calculations. That is what is really important here. So again, coming back, so this is going to be the given word, right? So all the S's should be together. This is going to be the question. In that case, what we will do here is, first of all, we will collect all the S's, all the S letters, all the letters S which we see here in this word, okay, fine, yes. So basically where we have the letters S here, we have 1, 2, 3, 4. There are 4 S occurring here in this word, is it or not? So that means we'll collect those S's here, okay. So it is yes, 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 yes. We'll collect these S letters here. And the other letters, now we will take the other letters, okay. What are the other letters? Other letters are going to be, except S, these 4 S letters, the other letters we can take it in order. So A, and then this A, and then we have INATION, okay. So these are all the things we have here in this given word. Now the task is all the S's are together. So that means make this S, this one as one single bunch, one single group, okay, fine, yes. So that means this has become one single object for us now. Why? Because since these S's should be together, that is what is posted in the question, right? So in that case, we will make this as one single bunch, and now count and see how many letters are here. I mean, how many objects are here for us, okay, fine, yes. Just be careful how many objects are here. We will count it and see. Now for us, this entire thing is like one single object, okay, fine, yes. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means there are totally 10 objects. So in how many ways can we arrange it? Number of ways is going to be equal to, number of ways is equal to, be careful here, there are totally 10 objects we counted, right? So it means to arrange those 10 objects, we have got how many ways? There will be 10 factorial ways, okay, be clear, 10 factorial ways. Hold on, we should carefully do it, okay. And now out of these 10 objects, be clear, out of these 10 objects, how many of them are identical? That we have to see, okay, all right. Now if you see here, there are, out of these 10 objects itself, how many of them are identical? If you see, there are 1, 2, 3 A's are there, okay, 1, 2, 3, 3 A's are there. So that means divided by, we have to divide it by 3 factorial, and it is not yet over. Hold on. Now we have to see the other letters also repeating. Now if you see, there are 2 I's are also repeating, is it or not? 2 I's repeating, so that means 2 factorial, and 2 N's repeating, so 2 factorial. See, these many things we have to look carefully, okay, fine, yes. So when you look at these 10 objects itself, these many repetitions are occurring. So 10 factorial by 3 A's 3 factorial, 2 I's 2 factorial, and 2 N's other 2 factorial. Fine, okay, done. And it is not yet over, multiplied by, because for each of these many arrangements, our S's also we have to look at, right? S. So how many S's are there? How many objects are here? There are 4 objects. That means 4 factorial. Again, that should be divided by, that 4 factorial should be divided by what? This should be again divided by, see here, how many of them are repeating? There are 4 objects which are repeating, so that means 4 factorial ways. I hope you are able to understand this. If at all the 4 objects are distinct, you will just write, we would have just wrote 4 factorial, that's it. But since there are 4 objects for which 4 factorial divided by all 4 are identical, All 4 of them are identical and dividing by 4 factorial, another 4 factorial. Okay, yes, I hope it is clear to you. Now if you complete this calculation, we will be able to get the final answer. Okay, yes, fine. So yeah, anyways, we can cut these 4 factorial, and we'll be only left with the other things. Okay, so let's carefully work this and get the answer. So what next can be done here is, be careful here. What we can do here is, of course, we have 10 factorial here, right? So this 10 factorial can be written as 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 factorial. I hope you are able to understand this. 3 factorial. Fine, yes. Why? Because by this time we got the reason. I am writing up to 3 factorial. Why? Because here denominator I have another 3 factorial. That's the reason. Okay, 3 factorial into what about this one? This is 2 factorial. This will be 2 again into another 2 factorial. That is again another 2. That's it. Very simple. Okay. Now what I can do here is, I will cut this 3 factorial with this 3 factorial. I can very simply do this. And what next I can do is, I have a 2 2s are with this 4, I can cut this. That also I can do it. Very simple, right? So this also I can do. So this is also over. And next, what are all the other things I can do here is, now that means the rest other numbers I have to multiply. Very simple. This is what I can do. So that means what we will do here is, we will just take down the other numbers. 10, 9, 8, 7, 6, 5. That's it. So the product of these numbers will give the answer for this question. So how we can multiply these numbers is, first of all, let's take a note of these numbers. Okay, what I will do here is, I will just multiply this 10 with this 8 with this 5. So what happens is, 8 5s are 40, 40 into 10 is 400. So I will take 400 and I will take the other remaining numbers now. Okay, what are the other remaining numbers? The remaining numbers are going to be 9 into 7 into 6. Okay, 9 7s are 63 and 63 into 6 we have to do. What is 63 into 6? So shall we multiply it separately? So we have 9 7s are 63. 63 into 6 we have to do. Okay, so 63 into 6, when you do it, you will be getting 360 and 18, right? So this will be like 360 and 18. So you will be getting the answer as like this will be like 8, 7 and 3, 378. So we'll have 378. This is what you will be getting here. So I think I'm right. So anyways, we can check it. These are 18, 6 6 are 360. Yes, it is going to be is 378. This is what we are getting. So 378 into 400. This is what finally you are supposed to do. So once again, this 378 into 400, we'll try to do it here itself. We can do it. First of all, I'll multiply 4 into 378. Okay, so 8 4s are is 32. Okay, I think yeah, this space is enough for us. So 4 8s are 32. So 2 here, 3 is the carry, and next 4 7s are 28 plus 3 is 31. 31 means 1 here, again 3 carry. Next 4 3s are 12. 12 plus 3 is 15. So 1 5. So 1 5 1 2 will come when I multiply 4 into 378. But this is not simply 4. This is going to be 400. So that means put 2 zeros next to that. So 1 5 1 2 00. This is going to be the final answer for your question number 6. Next is question number 7. Another interesting question with us. How many different numbers can be formed out of all the digits of the number 1 1 1 2 2 3? So that is using the digits of this number 1 1 1 2 2 3. I mean, we have to use all the digits and we have to form new numbers, new different numbers. In that way, if we try to form new numbers, how many numbers we can form? This is going to be the question. So this question has got another part also. Okay, there are actually 2 parts here. Okay, so other part is this. The continuation part is, how many of these numbers are greater than 3,000,000? That is 3,000,000 and 00, or we can tell 3 lakhs. This is going to be the question. Okay, so first of all, we have got out of the 2 parts. The first thing is like totally how many numbers we can form, and second part asks precisely how many of them are greater than 3 lakhs. This is going to be the question. Okay, it looks very interesting. The way of solving is also very interesting and very easy also. So previously we dealt with what? Mostly words, right? Words and letters we dealt with, but this time we have a question based on digits, numbers and digits. Okay, all right, that's all we have here. So first of all, we'll note down the number what we have with us. Okay, our number is 1 1 1 2 2 3. So that is our number is going to be, when we just call it out, the number will be nothing but 1,11,223. This is going to be our number, right? Yes. So how many digits are here? Actually, this is going to be a 6-digit number. Is it on? By looking itself, we can easily come to the conclusion. So there are 6 digits. This is a 6-digit number, and this is a 6-digit number, but this 6-digit number is constructed with how many digits? How many distinct digits? If you see, there are only 3 distinct digits available. Is the point clear? Though the number is a 6-digit number, we have got how many distinct digits that we have to see. Okay, if you see the number of distinct digits, there are only 3 distinct digits, which are going to be 1, 2 and 3. This 1 is 3 times repeated. This 2, the digit 2, this is 2 times repeated, and 3 is not repeated. It appears only once. Okay, so this is how a number is constructed. Now we have to see totally how many numbers we can form using these 6 digits. This is going to be the question. Okay, so I'll write it as, maybe I'll write it as the first subdivision. Okay, first subdivision, the total number of ways we can form. Total number of ways. I mean, I'll try to answer the first part of the question, which is going to be what? Totally how many numbers we can form. This is going to be the question, right? So totally how many numbers we can form? Very simple. There are how many digits available? There are 6 digits. Okay, so 6 factorial, but it is not yet over. Divided by. Now see the repetition of the digits. If you see the digits repeated, so 1 is repeated for how many times? 3 times it is repeated, right? So 6 factorial divided by 3 factorial, and any other digits repeated? Yes, this 2 is also repeating, right? 2 is repeating for 2 times, so divided by 2 factorial, that's it. Okay, and nothing for 3, because 3 appears only once, so we need not mention it here. So 6 factorial by 3 factorial into 2 factorial. This is going to give you totally how many numbers we can form using these digits. Okay, so let's try to simplify this. If you try to simplify, what happens is the 6 factorial can be expanded as what? This can be written as 6 into 5 into 4 into 3 factorial divided by. Now see here we have another 3 factorial. That's the reason I stopped till 3 factorial. Into here we have 2 into 1, which is simply 2, right? So that means I can cut this 3 factorial, and I can cut this 2 with this 4. This is exactly 2 times. So that means our answer is going to be 6 into 5 into 2. Already 5 2s are 10. 10 6 are 60. So that means our answer is going to be 60 is the answer. I hope it is clear to you, right? So I hope you can understand this. Very simple. So instead of letters, this time we have digits. That's it. That's the only change. But the concept is the same, and the approach we take to solve the problem, that is also same. Okay, so totally 6 digits. So 6 factorial divided by. Now see the repetitions. 3 ones for which 3 factorial, 2 twos for which 2 factorial. Now you simplify, you get the answer to be 60. Okay, now this is going to be the answer for the first part of the question. Now the second part of the question is asking for what? How many of these digits are greater than 3 lakhs? This is going to be the second part of the question. So I think I'll write it as subdivision number 2. Okay, though it is not mentioned in that way as question, so maybe for us to have a distinction, I mean like a differentiation, we'll have it like this. Okay, fine. Yes, yeah. So like here we have the second subdivision is asking for how many of them are greater than 3 lakhs, right? So now you think of, if my number which I am going to form using these digits has to be more than 3 lakhs, and then in what way we can form our number? Then definitely, now see the digits. I have 1 1 1 2 2 and 3. Then in order to make our number more than 3 lakhs, then definitely the first digit we have to form, I mean with which we have to form our number, should be this 3 only. Is it or not? Because our number is a 6-digit number, right? So definitely our first digit should be 3, and then we can fill the other 5 digits, because totally 6 digits. The first digit I filled it as 3, and the other digits I can leave it as it is. Okay, now hereafter there is no condition. Okay, now the other 5 digits I can fill it in any order I want. Okay, I can fill it in any order I want, because there will be there will be 3 ones and 2 twos available, right? There will be 3 ones and 2 twos available. Okay, so these are all the other digits we will be having with us now. These digits I can fill it in any order I want. Now if you try to see this way, if you try to construct your number, it will be definitely greater than 3 lakhs. You accept it? Yes, fine. So that means now the number of ways will be, I mean the numbers greater than, okay, number of numbers greater than 3 lakhs. Okay, the number of ways with which we can form this one is going to be what? Now the first slot is fixed. Okay, we can't touch this one. Now there are only 5 objects to be arranged. Okay, what are the other 5 digits? 1 1 1 2 2. it is enough if we just see the arrangements for these 5 digits alone. Okay, now there are 5 digits. These 5 digits can be arranged here. In how many ways we can arrange it? There are 5 digits, so 5 factorial divided by, be careful here, divided by. Now see here what we have here. Here we have 3 ones, so 3 factorial, and 2 twos, so 2 factorial. Okay, is it or not? Yeah, yes. So 5 factorial, totally 5 digits. So for which 3 ones repeated, right? So 3 factorial, 2 twos, and 2 factorial. Okay, that's what we have. Now we simplify this one to get our answer. Very easily we can simplify. This will become 5 into 4 into 3 factorial divided by 3 factorial into, this is 2 factorial, which is 2. Now I can cut this 3 factorial and 3 factorial. Now I am simply left with this 4 and 2, which is exactly 2 times. So 5 2s are 10. So that means here we got the answer as 10. Okay, I hope the approach is clear to you. So the first part of the question is asking for totally how many possible numbers we can form. Answer is 60. And the second one is asking for, the second part of the question is asking for how many numbers we can form using these digits in such a way that the numbers should be greater than, the numbers are greater than 3 lakhs. This is going to be the question, and for which the answer is going to be 10. And these are going to be the answers for your question number 7. Next we have question number 8 with us. Here, how many numbers greater than 1 lakh? So if you see this number, this is going to be 1 lakh, right? Because you have 1 followed by 5 zeros. So that means this number is 1 lakh. Can be formed by using the digits. Okay, we have some digits given here. So what are the digits here? We have 2, 4, 2, 3, 0 and 2. Taken all the digits together. Okay, fine. Yes, so that means we have to take all the given digits and we need to form numbers. And important condition is, what is the condition? The numbers should be greater than 1 lakh. This is what is the question's condition. Okay, all right. So that means our number should be, the forming number what we form, that number should be greater than 1 lakh. We'll note it. And at the same time, we have to use only these digits. So what are the digits here? The digits are going to be 2, 4, 2, 3, 0, 2. So these are going to be the digits. Fine. Okay. That means if you count totally how many digits are here, there are totally 1, 2, 3, 4, 5, 6 digits are here. So that means we have to form a 6-digit number. This is going to be the question's condition. And at the same time, if you notice, just see these digits. Are these digits distinct? That also we have to see. Okay, that means how many distinct digits are available here, that also we have to see. So if you see the distinct digits, distinct means without repetition. If you see that 0 is there, and the digit 2 is there, and 3 is there, and 4 is there. So only 4 distinct digits are available. So that means totally there are 6 digits, but if you see the distinct number of digits, there are only 4 digits available. 0, 2, 3, 4. And among which the digit 2, if you see, the digit 2 is appearing for thrice, 3 times. Okay, that means there are 3 2s here. This is going to be the question's content. So I hope now you are clear with the question. Now using these digits, we have to form numbers which are going to be greater than 1 lakh. This is the question's condition. So obviously we need to form 6-digit numbers only. Now think of if our number has to be more than 1 lakh, then in what way our number can be? Just see here, I can form 1, 2, 3, 4, 5, 6. I can form a 6-digit number. Is it or not? That means our number should be more than 1 lakh. That is the question's condition. In that case, what can be the first digit of our number? This is what I am coming to ask here. So that means this digit can be filled with any of which among these digits? That's what we have to think. Can you possibly fill this digit as 0? Is it possible? Just think of, if you come to fill this digit, this first digit with 0, can your number be more than 1 lakh? No, definitely not possible. So that means here the digit 0 is not allowed. That is what we have to think. Okay. So except 0, we can fill this digit with any of the other digits. This is going to be the idea. Okay. That we have to be clear. Only then our number will be more than 1 lakh. That is what I am coming to say here. That's it. Very simple. Okay. All right. So that means let us take each of those cases. We will take each of those cases. Okay, be careful. That is, there are, when you see distinct digits, there is 0 and there is a 2, there is 3 and there is 4. And just now we came to a conclusion that we cannot have 0 here. That is not possible. So the 0 is ruled out of this first digit, this place, okay. Now let us see the other digits. We have the other digits, right? Because our number can start with any one of these digits. So in that case, we will see each one case. That's what we are going to do now, okay. Now let us try to see what if our number starts with the digit 2, that we will see, okay. So starting with 2, suppose if I fill this digit with 2, then how many numbers I can form? That is what we are going to think now, okay. All right, yes, fine. So that means this digit, we have filled it. We cannot touch this one. Now we can fill the other 5 digits with the remaining 5 digits what we have here. Okay, what about the other 5 digits? So the other 5 digits are going to be another 2, okay, because 1 2 is already filled here, and we have another 2 more 2's are there. 1 0 is there, 1 3 is there, 1 4 is there. These are all the rest digits, the remaining digits available, okay. Now I can arrange those 5 digits in these 5 slots. So in how many ways we can arrange those 5 digits? That's what we have to think. So that means very simple. The other digits are what? Just be careful. See, remember, we have already filled the first digit with the digit 2. This first slot I am filling with 2. Now you have to concentrate only on the remaining available digits. Be clear with that, okay. So remaining digits are what? 1 0, 2 2's. See here, I am just plotting and showing you, okay. 1 0, 2 2's, 1 3 and 1 4. So these are the 5 other digits available with us. Now these 5 digits can be can be filled in how many ways? That is what we have to think, okay. So there are 5 digits, so that means these 5 digits can be arranged in how many possible ways? 5 factorial, just hold on, be careful here. 5 factorial divided by, 5 factorial divided by, why divided by? Because out of those 5 digits, there are digits, some digits are repeating. There are some digits repeating, right? So which digits are repeating? This 2 and this 2. There are 2 2's there. So that means while you come to arrange 0, 2, 2, 3 and 4, totally 5 digits. So 5 factorial, that has to be divided by repetition. 2 digits are repeating. Like 1 digit is repeating twice. So for which I have to divide it by 2 factorial. So 5 factorial by 2 factorial. So what you get as your answer here? 5 factorial by 2 factorial is going to be what? 5 factorial is 120. 120 divided by, this is 2 factorial is 2. So 120 by 2, it is going to be 60, right? 120 by 2 is going to be 60 only, right? Yes. So this is 60. So that means starting with 2, you can form 60 numbers. This is going to be the meaning. I hope now the idea is clear to you, okay? So starting with 2, it is done. Now the same thing we are going to do by starting with 3 and starting with 4. Yes, shall we quickly do this? Yes, I hope now you got the idea. Fine, yes, yeah, yes. Dash, 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 dash. Now starting with 3, now we will think of this. Starting with 3, how many numbers we can form? That we will think now, okay? Now the first digit is going to be 3. So I am going to fill this first digit with 3 and the other 5 digits are remaining left over. Now carefully think of what are the other 5 remaining digits are left. Now if you see, there's 1 3. 1 3 is filled here. There's only 1 3 only in our list. So this 3 is filled here. Now what about the other digits? Other digits are, there is 1 0 and there are 3 2's. Remember, now there are 3 2's there. 2 2 2. There are 3 2's and there is 1 4. So that means 0 2 2 2 4. These are the 5 remaining digits available. So that means they can be arranged in this 5 slots in 5 factorial divided by, now what should come there? Just think of. So 5 factorial divided by how many digits are repeating here and how many times it is repeating? Yes, the digit 2 is repeating for thrice, 3 times. So that means 5 factorial by 3 factorial. This is what will come there. Yes, fine. So 5 factorial by 3 factorial is going to be, the answer is going to be 120 by 6, which is going to be 20. It is going to be 20. Fine. Yes. All right. Yeah. Now 3 is also, starting with 3 is also over. And next I am going to start with the digit 4. Okay. Now starting with 4. 1, 2, 3, 4, 5, 6. 6 digit number. Now the first digit is going to be 4. Remember, see something here. Don't just take this as 2 ways, 3 ways and 4 ways. It is not like that. That is not like that, okay? These are not the number of ways. These are the digits that we are placing there. Okay, fine, yes? So in the case, don't count it as a number of ways. That is that is going to be a huge mistake. That's the reason, okay? So this is going to be like, those digits are going to occupy that position, that place. That is the meaning, okay, all right? Now we are doing the calculation here for the other 5 slots only. That we have to think, okay? Once these digits are filled in those places, they are fixed. We can't touch there. That's the reason. And the other 5 digits number of ways is what we are doing here in the calculation part. Okay. Yes, same way 4. When you start with the digit 4, now what happens? Now this time what will happen? So you are taking this digit 4 and making it occupy the first slot. And what are the other 5 remaining digits? Now this time we will be having 1 0 and 3 2s. Again 3 2s will be there and 1 3 will also be there. Is it or not? So this time also there will be 5 other remaining digits only. So 5 factorial divided by, and this time also what happens? The same digit 2 will repeat for 3 times. So that means 5 factorial divided by 3 factorial. So again it is going to be what? The same 20 only, right? Like as before what you had here. Same way, this is also 20. And now this time 4 is also done. Okay, so that means only these are the possibilities. For our 6-digit number should be to be greater than 1 lakh. These are the different possibilities. Either one of these can only happen. So in that case, our overall answer will be what? Just add all the possibilities, either this can happen or this, right? So 60 plus 20 plus 20, your overall answer is going to be 100. So that means total number of ways or total number of numbers we can form using these 6 digits, that too greater than 1 lakh, is going to be what? The answer is going to be 100. This is going to be the answer for your question number 8. Now we are with the last question of this exercise, question number 9. Here our question is, how many arrangements can be made with the letters of the word mathematics? So our given word is mathematics, okay, and followed by which we have, if there are few conditions, there are some subdivisions. Let's work those subdivisions one by one. So the first subdivision we have here is, if there is no restriction. So there is no restriction at all, any letter can come in any place. Fine, okay. So if there's open, the problem is very open, no restriction, then how many ways it can be done? How many ways we can arrange the letters? This is going to be the question. So very simple, but it involves some big calculations. There only we should be careful. Yeah, let's take our word mathematics. That's going to be our word, right? So let's take the word mathematics. So here we have total number of ways. Total number of ways will be equal to, number of ways I'll write as number of ways. Number of ways is equal to, I think this space is enough. So let's take our word directly, okay. So our word is going to be MATH. So how many letters are here? Directly we can get the count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters are there. So that means we'll have 11 factorial divided by, and now we have to see the repetitions, right? So how many letters are repeated and for what many times, that is also important. So if you see the letter M is repeating for 2 times, so that means 2 factorial. And next we have the letter A is also repeating twice. A is here and A is here, so again another 2 factorial. And you have T and T is appearing for twice, again 2 factorial. And any other letters repeating, the other letters are H, E and then I, C, S. No, there's no repetition. So that's it. This is what we will be having here. So that means we will have our answer to be equal to 11 factorial by 2 into 2 into 2, because 2 factorial is going to be 2 only, right? So 2 into 2 into 2. So let's do something here. 11 factorial, let me try to expand 11 factorial, okay? So what happens is 11 into 10 into 9 into 8 into then 7 factorial. I have a reason for 7 factorial, writing 7 factorial divided by, okay, though you don't have any 7 factorial in the denominator, I am just stopping here, okay, fine, yes, because we also know the value of 7 factorial, right? So 7 factorial, we know the value is 5040, right? Yes. So divided by, just come to the denominator. Denominator is nothing but 2 into 2 into 2, which is going to be simply 8 only, is it or not? So now I can easily cut this 8 and 8. For that reason is what I did like this. So now we can do our common calculation. So what here we can do here is, see here we have 11 into 10 into 9 into 7 factorial. That's all we have here. And now if you see carefully, I will just pair up this 11 nines are will be 99, which should be multiplied by, what about the 7 factorial? 7 factorial is actually 5040, right? So 5040, but along with that we have to include one more 0 also, because we have a multiply by 10 also, that's the reason. So 50400. So in order to complete our answer, this is what we'll be getting. So we'll have 99 times of 50400. This will be our answer. So now we have to calculate the value of this one. So this is what we are supposed to do. So what logic we can apply here is, we'll do a simple thing. So I will just take this calculation something like this, okay. So maybe for comfortability I'll write like this. 50400 is what we had, right? So I'll write this multiplied by 100. Okay, just for a calculation comfortability, I'm doing this. So now if you see what happens is, I have 504 into 99 into 100. Okay, first we'll complete this calculation, 504 into 99. Okay, so maybe I can use the space which is free over there. So 504 into 99. Okay, we'll do our usual trick. First of all, 504 into 100 will be 50400, and from which I have to minus 1 504. 504, I can minus this, I can easily get our answer. Is it or not? We can easily get the answer. So what we can do here is, I will borrow 1 so that this will become 100 and this 4 becomes 3. And now what next I can do here is, I will take 100 minus 4, which will be 96. And here I have 503 minus 5. What is 503 minus 5? It will be 498. So 498. So I will have 99 times of 504 to be, see the answer? It is nothing but 498, then 96, and followed by this 00, because I have a multiply by 100. That's the reason. So yes, cool, we have finished the answer. So this is the way we can somewhat smartly multiply and get the answer. So I think the calculation is also working well. So 498, 96 and 00. That's it. Okay, so this is going to be the answer for your first subdivision. Now coming to the second subdivision, here we have vowels occur together. So our same word, mathematics, in how many ways we can arrange in such a way that the vowels in the letters are together. Vowels should be together. This is what, okay, and we are very much used to this condition also. So whenever we have this kind of vowel should be together, these things, we know what approach we have to handle. So just collect the vowel letters first. Okay, now take our word and take the vowel letters first. Okay, so what are the vowel letters here? Vowel letters are going to be, A is a vowel, then next E is a vowel, then again M, then again one more A is there, that is a vowel, and T is there, and I is there, I is a vowel. Okay, so A, E, A, I, that's it. No other vowels are there, right? So the rest are all consonants only. Say, fine, yes, yeah, A, E, A, I. So that means these vowels should be together. This is going to be the condition. And what about the other letters? They are all going to be consonants. We'll write the other letters. Okay, other remaining letters are M, then T, then H, then again M, then again T, then C, yes. So these are all the other letters which are left. Okay, so if you see these are the letters. So now among these vowel letters should be together. That is going to be the question's condition. So that means we will make them as one single bunch. And now what happens, wherever we carry it, it will come as a bunch itself. So this becomes one single object for us now. Okay, so that means if you see how many objects we have here, we have number of objects before us, we have 1, just count it as 1. Okay, because for us now this is one single object. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So there are totally 8 objects. So 8 factorial, just be careful, 8 factorial. Hold on, 8 factorial. Among these 8 objects, how many of them are identical? That also we have to see, right? So among which identical objects are, see here, we have this M is repeating, right? M is repeating twice. So 2 factorial. And then this T is repeating twice, again another 2 factorial. Be careful, right? We have to see that identical also. Among these 8 objects, there are 2 identical, other 2 identical. So 2 factorial with which we are dividing. So this is over, and multiplied by, for each of these many arrangements, what we have to see? We have to see the vowels, that vowels within themselves, they can be in whichever order they want, right? So that means these vowels, number of ways we can arrange, that also we have to see. Of course they should be together, but within together they can be in any possible order, right? So for which what we have to do is, we have to see these vowels. There are 4 letters here, right? A, E, A, I, there are 4 letters. So 4 factorial, we can arrange them in 4 factorial ways. But again, hold on, among those 4 letters, there are 2 identical letters inside. Is it or not? Be careful. Okay, so A, E, A, I, there are 2 A's there, right? So for which again I have to divide by a 2 factorial. I hope each and every number, the factorial what I have written here, you are very clear about it. Yes, you must be very clear about it. It's very, very important for you to understand. Okay, only then you can get the logic. Okay, so why we have written this 8 factorial, this 2, 2, 2, 4, 4, 2, everything, that you should be very clear. Okay, let me just quickly tell that this 8 factorial stands for these 8 objects, among which these 2 M's and these 2 T's are identical. 2 factorial we are dividing. And next is, for each of these many arrangements, we have to see the number of arrangements of the vowels also. Vowels are 4 factorial, 4 objects, so 4 factorial divided by 2 of them inside them. Among the vowels itself, two of them are identical. So we are dividing by 2 factorial. Okay. Yes. So now we complete this calculation. We can easily get the answer. So what can be done here is, I will write this 8 factorial as 8 into 7 factorial. Okay, hold on, 8 into 7 factorial multiplied by this 4 factorial and divided by, now what about the denominator? We have 2 factorial, 2 factorial, 2 factorial, that becomes 8. That becomes 8, simply 8. So now I will just cut this 8 and 8. This is what, this is my plan. That's the reason I've written like this. So now all we have here is 7 factorial into 4 factorial. This alone we complete, we can easily get the answer. So what is 7 factorial? 7 factorial is 5040. Correct? Yes. 7 factorial is 5040, 5040 multiplied by, what is 4 factorial? 4 factorial will be 24. So 5040 multiplied with 24 will give you the complete answer. Yes, I think this we perform it. This itself is enough for us to get the final answer. Okay. So let's work this calculation carefully. So how we can do this calculation is, first I will do something. Okay, I will multiply 5040 into 20. 5040 into 20, I will do that first. Okay, so 5040 into 20 if I do, I will be getting, let me write it separately. Okay, I will be getting, so 8, 80, 100, again one more 0. Okay, this is what I will be getting when I multiply this 5040 into 20. Okay, and this 5040, now if I try to multiply with 4, now what happens if I multiply with 4? What will happen here is, 4 into 40 will be 160, it will be 160, and 4 into 50 will be 200, is it or not? So this will be 200. So we have to place the digits very, very carefully. That is also important. So what happens is, like this will become 4 into, this will be 160, 4 into 5000 will be 20,000. So this becomes 20. So now I have to add everything to get my final answer. So this will be 960, this will be 0, this will be 1, this will be 12120. So 120960. This is going to be the answer. So maybe if you want, you can check it once. How, yes, 5040, 504, 180. So yes, yeah, yes, it's working. So 120960 is going to be the answer. So that means vowels are together. How many ways we can arrange this? 120960. This is going to be the answer. I mean, like 1,20,960 is going to be the answer when you arrange vowels together. Okay, now coming to the third subdivision, here we have all vowels don't occur together. Okay, just be careful, very careful with this calculation. Okay, just be very careful, be careful with the words they are using. Okay, all vowels don't occur together. What do you mean by that? What do you mean by all vowels don't occur together? So the meaning is, not all the vowels are together. Okay, this doesn't mean that vowels should not be together. All the, I mean, like the vowels, each vowel should be separated. I mean, like any two vowel should be separated. That's not the meaning. Okay, so here the meaning, the thing what they are coming to convey here is, all vowels don't occur together. That means I'll just try to show it with this example itself. Now see here there are 4 vowels in our word. Okay, 4 vowel letters in our word. These 4 letters are together here. Okay, now this meaning is all vowels don't occur together. The meaning here is, be careful in understanding that here all the 4 letters are together, whereas when you come here, these four letters, they can be present in such a way that either 2 of them can be together and the other 2 can be together. Or it can even be like this, 3 of them together, 1 vowel separately. Or it can be like 1 vowel separately somewhere here, the other 3 vowels are together. Or it can even be all the vowels are separated. Or it can even be like 2 of the vowels are separated and 2 of the other vowels are same together. Okay, it can happen in any possible ways. So that is the thing what they are coming to tell here. Okay, the meaning what they are coming to tell here is, all vowels don't occur together. The meaning here they are coming to convey is, the vowels, it is not necessary that they should be always together. Okay, it can also be separated. It can be separated in any possible ways. The only thing is, they all should not be together, except that it can happen in any possible ways. They all 4 can be separated, or 1 can be alone, the other 3 can be together, or 2 of them alone, the other 2 can be together, or 2 can be separated, the other 2 is together. It can be any other possible way. So that is what is the meaning they come to tell here. So that means, to answer this, you can do a very simple thing. You can just get the total possible ways, the total number of ways from which you can minus vowels are together. Okay, vowels are together. Okay, so from this total possibilities, once you come to subtract this vowels are together from this total, okay, we already calculated the total here itself. From this total possibilities, once you subtract this one, you will automatically get the answer for this question. Okay, fine. Yes, that's it. Very simple thing. So to total, we know total is 4989. Okay, let me note it, 4989. And then we have a 600, 498 600. This one minus, we have to minus this, okay, because out of these possibilities, in these possibilities only vowels are together. The other possibilities, the vowels will not be together. That's it, okay. The vowels can be separated, either two of them will be there, the other two will be there, or three together, or one separated, whatever, okay. We need not worry about each of those cases. That is not at all important. Just the thing is, except this, what any other can happen, that is what is mentioned here. That's what, okay. So minus, so I will take this one, 120960. This is what we have to do here. So once you do this subtraction process, you can easily get the answer. So that means here we will be getting the answer as, I will take this as 100. I will borrow 1 from the 6. So this 6 becomes 5. So now what happens is 100 minus 60 will be 40. So subtraction sometimes looks funny, and also the way we approach, that is also important. That's why. So now we have 95 minus 9. So what is 95 minus 9? It will be 86. Do it smartly, okay. 86. And what next I have? Hereafter there's no complex, I think. There's no complexity. 8 minus 2 is 6. 9 minus 1 is 8. And this will be 4, as it is 4. So 486, 8640. So this is going to be the answer for your third question. So I hope it is clear to you now. Yes, fine, yes. So first subdivision, they are coming to ask what is the total number of ways. If there's no restriction, that's the total number of ways. Second one, they are coming to ask what if the vowels are together. With our general approach, we got the answer. And third one, what happens if all vowels are not together, okay. All vowels don't occur together, for which from the total you minus vowels are together, you can automatically get the answer for this one. And this is going to be, these are going to be the answers for your first 3 subdivisions. Now subdivision 4 says the consonants occur together. So the same given word, mathematics, here the consonant letters should be together. That is going to be the fourth subdivision. So first of all, let us take our word. So we have the letters, and here our objective is we have to collect all the consonant letters together. Okay, all right. So that means we'll take the consonant letters. So previously we tried the vowels together, but this time we have consonants together. So that means first we will collect the consonant letters. Okay. So we have M is a consonant, so write M here. Next, what are the other consonants? T is a consonant. Next, H. Next, leave E is a vowel, and next again M comes, and then leave A. Then T will come. Then I is gone. Then C will come. Then S will come. So that's it. These are going to be the consonants, and the other remaining letters will come now. So what are the other remaining letters? Remaining letters are going to be vowels only. So the vowel letters are what? A, E, A, I. That's it. Correct? Yes. So yeah, A, E, A, I. These are the vowel letters. So this time we have the consonants together. So this is going to be the question's condition. So when consonants are together, this time we have to collect all the consonants and put them inside one single bunch. This is what we have to do here. So this can be arranged in how many ways? This is what we have to think now. So now if you see, totally how many objects are there? Look here, this is going to be one object for us now. 1, 2, 3, 4, 5. There are only 5 objects now. So 5 factorial. So 5 factorial ways we can arrange these 5 objects. And among these 5 objects, be careful, among these 5 objects, there are 2 A's here. They are identical. So 2 factorial, 5 factorial by 2 factorial, not yet over, multiplied by. When the consonants can be together, they can be arranged within themselves in any possible order. Okay, that we have to think. So if you see these consonant letters, how many letters are there? So there are 7 consonant letters, right? So 7 factorial divided by, what we can do here is, now see the repetitions inside the consonants. There are 2 M's, so 2 factorial, and then 2 T's, again 2 factorial, and that's it. Okay, no other repetitions are there. So that's it. So 5 factorial by 2 factorial into 7 factorial by 2 factorial. This is the answer we are getting here. So that means this will be equal to, I think they are not very huge numbers. I can cut it directly. So I have 5 factorial is 120 and 7 factorial is 5040. So 120 by 540 divided by, we have 2 factorial into 2 factorial, which is nothing but 2 into 2 into 2, which is going to be 8. Correct? Yes. Now I can cut this 8 and 120 for exactly 15 times. because 15 8s are 120, right? 15 8s are 120, so 15. So we are simply left with 15 into 5040. This is going to be our answer. So 15 into 5040 will give us what? It will give us, so I think we can work it out separately. Okay, so I think this space is enough, not a very complicated calculation. 5040 multiplied by 15. So first of all, I will do 5040 into 10. So 5040 into 10 will be 50400, and 5040 into 5 will be half of this. This will be 25200. So that means my overall answer will be 75600. That's it, very simple. So 75600 is going to be the answer for your fourth subdivision. Yes, I hope it is clear to you. Now coming to the fifth subdivision, here we have, in how many ways we can arrange the letters in such a way that the letter M is at both extremes. Be careful, the letter M should be at both extremes. This is going to be the condition. So that means, see our word, given word here, our word is mathematics, right? And here we have two M's available, right? So that means the word, what we are going to arrange, it should have M at both extremes. So that means what? Our letters, I mean our word, what we are forming, it should start from M and it should end with M. This is going to be the condition. Okay. Totally there are 11 letters, right? There are totally 11 letters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters. So it should start with M and you should have the other remaining 9 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then again last M. So this is how we have to arrange these letters. This is going to be the question's condition. So if in this way, if you are going to arrange, then how many ways we can form? This is going to be the question. So now our task is like what? Since our letters are, our word is going to start with M and end with M. So what happens? So these two slots are fixed. We can't touch them. So they both are fixed and we can arrange the other remaining 9 letters only. That is going to be the task. So the number of ways to arrange those 9 letters is how much? That is all we have to think here. So 9 letters we can arrange in how many possible ways? We have 9 factorial ways. So we have 9 factorial ways in which we can arrange these letters. But 9 factorial divided by, we have to see the repetitions also, right? Yes, fine. We have to see the repetitions. Leave the M's. M we are not going to touch, okay, because M starting with M and ending with M, they both are fixed. Other remaining letters only we have to see. So see the repetitions from those letters, okay. So in those letters, what repetitions we have? We have 2 A's there, so divided by 2 factorial, and again we have 2 T's appearing, so 2 factorial. I think this is over, right? So there are no other repetitions. So 9 factorial by 2 factorial, 2 factorial. When you complete this calculation, you can easily get the answer. So this will be equal to 9 factorial. When you expand it, it becomes 9 into 8 into 7 into 6 into 5 into 5 into 5 into 4 factorial, right? 5 into 4 factorial. No, 5 into 4 into 3 factorial. Let me write as 3 factorial. So I think that works better. So yes, 3 factorial. Okay, divided by this will be 2 into 2, which will be 4. Simple, right? So that means I can now cut this like this, 4 and 4 I can cut this. So now I am left with these many calculations. This I have to work out very carefully. Yes. Oh, so our answer will become 9, 8, 7, 6, 5, 4 is cut and then 3 factorial. Okay, yes. So what way we can do this calculation? We should see some easy possible ways to do this calculation. So in that case, if we think, I can just pair this 9 6R will be 54, 8 7R will be 56 into 5 into, what about this one? This one will be 5 into 3 factorial, right? 5 into 3 factorial will be how much? 5 into 6, 5 6 are 30. That's it, simple. So that means our answer will be 54 into 56 into 30. So what about 54 into 56? We'll use our classic technique. 55 minus 1, 55 plus 1. So this means this will be 55 square minus 1 square, which will be 3025 minus 1, which will be 3024. 3024 into 30. So this will be 3024 into 3 will be basically 9072 followed by a 0. That's very simple. We finished it. So answer for your fifth subdivision is 90720 is going to be the answer. Very good. Yes, done. Yes. So once again we check it because we did in a hurry. So yes, yeah, yes, it's working. So 90,720 is going to be the answer for your subdivision number 5. Okay, now coming to the last subdivision, subdivision number 6. Here we have order of vowels remain unchanged. Very brilliant way they have framed this question. Okay, so we should carefully think about what this question actually means. That's what is even more important. Okay, order of the vowels remain unchanged. I think it would be better if we spend a small time here, okay, a short time here. So like how I can tell here is, we'll just try to see some examples that will give you a good clarity on the meaning of what they're coming to convey here. So you take our word mathematics, okay. Now if you see our word mathematics, here we have vowels. How many vowels do we have? Here we have 4 vowels available, right? A, E, A, I. Actually, this question they are coming to ask, these 4 letters position should not be changed. I mean, positions can be changed. I'm sorry for that. Positions can be changed, but the order in which they are present, that order should not change. So wherever those 4 vowel letters appear, they should appear in the same order. That is what they're coming to say. I think now we are getting some clarity, right? So A, E, A, I, that is the way you have the 4 vowel letters here, is it or not? So that means those 4 vowel letters, wherever they appear, in whichever positions they appear, they must appear in the same order. A first, then E next, then again another A, then I. This is the way they should be present, okay. This is what they're coming to ask here. So just for an example, if I want to give an understanding, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So totally there are 11 letters here. So there's nothing to worry about the consonants, positions, their orders. That can be changed in whatever order they want. Okay, that does not mention anything here. So what simple thing they're coming to ask here is, these 4 letters, vowel letters alone, should be same in the order. Should remain in the same order. That is what they're coming to ask here. So in that case, what we can do here is, we can fill the other 7 consonants in whatever slots and in whatever order. Okay, after filling those 7 consonants, maybe for an example, I'll randomly take some 7 places. Okay, 1, 2, 3, 4, 5, 6, 7. Suppose I'm filling the 7 consonants in these 7 slots. Now there are 4 other slots left, right? 1, 2, 3, 4. Now in those 4 positions only we should have the vowels. So the meaning of this subdivision is, in those 4 slots the vowels should appear in the same order. That's the meaning, okay. A, E, then A, then I. This is the way they should come. So A here, then E, then A, then I. This is not only for this particular case, it can be in any case, okay. So maybe the first 4 positions can also be occupied by the 4 vowels. Then the other remaining following other 7 positions you can have the consonants, okay. But in those first 4 positions where the vowels are going to occupy, they must follow the same order, A, E, A, I. That is what they're coming to tell here in this question, okay, fine, yes. So if this is the case, then in what approach we can handle, what approach we can take to solve this problem? That is what we have to think here. So just be clear with the idea what we are going to do here. If at all the vowels order need not be changed, our only thing is we have to just arrange only the 7 consonants. That's it, okay. So in that case, what simple thing we can do is, you just take all the vowels to be identical objects. Very simple. We can take them to be same objects, identical objects. That's it, okay. Fine, okay. Anyways, they are going to occupy some those remaining slots in the same order, right? The order wherever they are going to appear, the order is going to be the same, right? So in that case, what we can simply do is, we will consider them to be identical objects. So in that case, out of these 11 objects, what we are going to arrange, 11 factorial, out of which the 4 vowels are like 4 identical objects. So that means these 4 objects are identical. In that case, we will take them as 4 identical objects. That means this is like 4 factorial. And now we can go for the remaining, okay. Now what are the other consonants? In consonants, what are the identical objects? So consonants, we have 2 A's. So 2 factorial, right? And then next we have 2, I'm sorry, this is not 2 A's, this is 2 T's, okay. I am very sorry, because A's will come under vowels only, right? So I am very sorry for that. This 2 factorial is for the 2 T's, okay. So 2 T's are there. Maybe I can tick like this, T here. So I can tick like this. Then what other letters? M is repeating, right? So the letter M is repeating. So M is repeating for twice. So that means again another 2 factorial, okay. So that means total 11 objects for which 11 factorial, which has to be divided by 4 identical vowels. since the positions, I mean the order of the vowels need not be changed, we can take them to be 4 identical objects lying over there, for which 4 factorial, and for 2 m's 2 factorial, and for 2 t's another 2 factorial. That's it. This will finish the problem. So I think when you solve this one, you can easily get the answer for this. So let's complete this calculation. So what can be done here is we have to expand. Anyways, we have to expand this. So when you expand this, we'll get 11, 10, 9, 8, 7, 6, 5 into 4 factorial divided by 4 factorial into 2 into 2. This is what we'll be getting. Yes. Yeah, yes. I can now cut this 4 factorial, this 4 factorial. They both are gone. What next I can do here is, yeah, I have 2 2's are 4 that I can cut with this 8. So this will exactly give you 2 times, because 4 in 8 exactly 2 times. That's what we get. Now we are left with what other numbers. Now we should carefully work out and get the answer. Once that is done, we can easily get the answer. So how nicely we can get this, we'll pair up the numbers and we'll group the numbers in a nice way. 11 9s are is 99. This is done. 11 9s are 99. And what next I can do is, yeah, here I have 7 6s are 42. This is also done. 7 6 are 42. And remaining are this 10. I'll round it. Okay, 10, 2 and 5. Now what about 10, 2 and 5? 2 5s are is 10, 10 10s are is 100. That's it. So I have 99 into 42 into 100. This calculation, this completed, if you complete this calculation, you can easily get the answer. So first of all, we'll try to do 99 into 42. That will be easy for us to do. So 99 into 42 will be nothing but 4200 minus 42. Simple, right? So the answer will be 4158. I can easily minus this 4158. So 4158 followed with the 00. Since we have a multiplication with 100, 415800 is going to be the complete answer. Okay, let me write it clearly. 415800 is going to be the answer for your 6th subdivision. Yes, successfully we are completing the last question also. I hope the approach is clear to you. Yes. So yeah, so this is for consonants are together. We did the same approach, and here m's are at both m's are at the 2 extreme positions. That also we just did. We solved like this, and this is a bit tricky. This is what is a little extensive part of this one. This entire part. So here they have asked the order of the vowels remains unchanged. So in that case, so this will be like the vowel letters alone, we are going to have them in the same order, for which we are considering them as identical objects and solving this problem, and that is what is giving us this answer. And of course, to say a small point, this concept is something that this gives you lead for a new concept, what you call it to be combination. So this topic itself is permutations and combinations only, right? So for combinations, this problem is a very good lead for you to understand this combination. Okay, when you come to see combinations, maybe when you work more problems, you will come to understand the essence of combinations concept, how it is applied here. But though we are, since we are playing only with permutations, it won't be that much fair when you directly jump into the combinations as of now. So just take this problem, you can take it as idea with what idea we have seen here. Okay, fine. Yes. So yes, successfully these are going to be the answers for the last 3 subdivisions of your question number 9. So yes, all of you, I hope the way we solve these problems are clear to you, and the approach we took, the concept, what are all the things we saw there, everything is clear to you. And this is going to be the solution of this exercise 7.4. Yes, I hope everything is clear, and if at all you have any doubts, you are most welcome to comment in the comment box, and when I see it, I'll see to rectify your doubts. Again, we'll catch up in the next session with other exercise solving problems. See you soon there. Thank you so much.